the thing is shown here, and you can see there is a feedback between output and input. So this resistance RF is going to act like a feedback resistance between the input and output of my circuit. So that is shown here, and some you can relate this to the collector to base bias. In BJTs, you have collector to base bias. You can relate this circuit to that. So in we are drawing the same thing with respect to FET. So here I have the feedback resistance between drain and gate of my FET. Usually where there you have between the collector and base, here you are having between the drain and gate of your FET. And the explanation is given here, and it is very obvious. It is going to act like a negative feedback, and this RF resistance is going to be acting like a bridge between the input and output side of the network. And in this case, both the input and output resistance are going to increase. The resistance are decreasing, so which will help us in increasing the bandwidth. Okay, so that is what is clear from this expression. See, I'm just going a little bit fast because these are basic amplifiers, what we know. And the input impedance, if you find, it is going to be a function of the feedback resistance. So it is going to have the feedback resistance term also in the expression R in approximately equal to RF by 1 plus RL by R1. Okay. RF is going to be the feedback resistance, RL is your load, and R1 is going to be the resistance. And output resistance, you see, it is going to be RF plus RS by 1 plus RS by R1. So if you take all the resistance to be equal to R, then you can have R out will be equal to Rn will be equal to this term. So you can find all these terms to be same. So in this case, the amplifier is going to provide perfect matching at the input and output ports. Okay. So once the impedance level is chosen, you can find out the bandwidth, and you can find the approximate bias point where the device has to find. And here here, since we are going to operate this device at a high frequency, the computation of FT or threshold frequency is very, very important. Where the current gain is going to be maximum. So that computation of FT is going to be very, very